In this video, we demonstrate how to set up and execute the Peltier Aging Diagnosis using Meerstetter Engineering's TEC configuration software. The goal of this test is to accelerate the aging process of a Peltier element through thermal cycling and to observe how its electrical resistance changes over time. This helps determine the optimal point in time for replacing a Peltier element. Before we start the Peltier Aging Diagnosis in the TEC configuration software, a quick look at the components used for this demonstration. A TEC controller from Meerstetter Engineering. A Peltier element. A heatsink. A thermal mass for heating and cooling. Some thermal paste. Screwdrivers for connecting. And a cable for connection to the power supply. Now, let's assemble the components. Now connect the TEC controller to the power supply unit and the PC. Now that we have assembled and connected all the necessary components, we can start with the settings in the software. First, open the free TEC configuration software from Meerstetter Engineering. We begin by setting up GPIO 3 and GPIO 4 for fan control. GPIO 3 is configured as a PWM output with push-pull mode, while GPIO 4 is used as a tachometer input with a weak pull-up resistor. This setup allows us to control and monitor the cooling fan connected to channel 2. Channel 2 is enabled, which powers the fan through the TEC controller. Additionally, fan controller 1 is activated to ensure adequate heat dissipation during testing. Next, ensure that the thermal model under temperature controller is correctly configured. Specifically, the parameters Imax and DTmax must be entered according to the datasheet of the Peltier element being used. These values define the maximum current and the maximum temperature difference that the Peltier element can achieve under ideal conditions as specified in the datasheet, not necessarily the maximum it can tolerate. To prepare the system, we configure PID control on the TEC. The target temperature is set to 65 degrees Celsius, which lies within the standard operating range. After the temperature has stabilized, auto-tuning is then performed to optimize control parameters. After the auto-tuning has been successfully performed, click on Write Results to confirm the results. The course ramp is set to its maximum value of 50 to allow fast temperature changes, and proximity width is set to 0. This ensures that the TEC controller applies the maximum possible current for as long as possible without starting to reduce power prematurely. The output current limit is set to 7 amps. Once the system has stabilized, we open the Extra Functions tab and select Peltier Aging. The diagnosis mode is set to single. This means the measurement will be performed once per cycle, triggered by the lookup table. Although not strictly required to enable the aging diagnosis feature, a lookup table is recommended for this test. It defines the temperature targets for the cycling process, typically between 50 degrees Celsius and 80 degrees Celsius. Temperature regulation remains active during the test. Once the lookup table is downloaded, the test is started and the system begins temperature cycling accordingly. Throughout the test, all connected temperature sensors are actively monitored. If any sensor detects an over or under temperature condition beyond defined thresholds, the system will interrupt the test and raise an error. These protections help to safeguard the hardware during extended aging cycles. During the test, live data is displayed in two graphs. Graph 1 shows the real-time temperature readings from the sensors. Graph 2 displays the electrical resistance of the Peltier element. As the resistance of a Peltier element increases with temperature, these graphs help identify typical thermal behavior as well as potential signs of wear or degradation. The test runs continuously until it is manually stopped or the Peltier element fails. One indication of failure is that the Peltier can no longer reach the target temperature, at which point a low temperature error may be triggered. For clarity, it's best to explain that the test ends either manually or when the Peltier element has reached the end of its life. This concludes the setup and operation of the Peltier Aging Diagnosis function. By cyclically stressing the Peltier element between 50 degrees Celsius and 80 degrees Celsius, engineers can accelerate the aging process and monitor how the electrical resistance changes over time. This provides valuable insight into the reliability and optimal replacement timing of thermoelectric elements. Thank you for watching this tutorial. You can download the TEC configuration software, firmware updates, and additional resources directly from our website. There you'll also find detailed user manuals, data sheets, and further documentation to support your work. If you're interested in our products, you can order all our TEC controllers, laser diode drivers, sensors, and more directly from our online shop. And if you have any questions or need assistance, don't hesitate to contact our support team. We are here to help. See you next time.